Hello and welcome to another episode of Gotham Sound TV. I am excited to be talking to Glenn Sanders of Zaxcom. Glenn, how you doing?
Hey Peter, I'm great. How are you?
I'm all right. We're here to talk about the URX100. So, first of all, we're going to talk about this. We're going to approach this like layers of an onion because I think that's the best way to deal with this product. And I am genuinely excited about this product. So, first of all, in its simplest form, I'm going to ask you a question, and I'm going to answer it too. What is it? It's an IFB. Fair to say? IFB receiver.
That is
in its simplest form.
A simple, small part of what it is.
All right, we'll peel the layers.
Okay, start.
So we'll start at its simplest form. Okay. So it's an IFB receiver. It is wideband UHF, and it receives its signal from any of Zaxcom's transmitters, UHF transmitters.
That is correct.
Right. So the first thing to know is that this is not Zaxnet based.
Correct, and I think we certainly need to explore how that differs from what people know.
Okay. Well, yes, I think so. So by making it UHF based instead of Zaxnet based, that means you get the benefits of UHF digital propagation. Specifically your encoding.
Well, yes. You absolutely get the benefit of longer range because UHF is always going to give you better range than the type of thing we've done on 2.4 gigs.
And so just the first most basic use case scenario that I can see for this, and it's a good one, is a UHF transmitter on the cart transmitting program to receivers, and you can hand this out to the general public, meaning directors, script supervisors, producers, or your crew. Now,
correct.
We're going to go one layer deeper into the onion, which is because it's your modulation schemes, Zaxcom's modulation schemes, I can transmit a stereo signal to this, meaning two channels. It doesn't have to be left-right stereo. It could be two discrete channels.
Absolutely. You could take the two channels. You can monitor them any way you want, whether it's left, right, center, and you can have different left, right, center for the left and right of the stereo coming in. Mm-hmm. So that you can have, let's say, the main mix track, let's say, centered, and then maybe the other side will be used for comms, and maybe that only goes to the right side of the monitoring.
And yes, absolutely, and that's you see that all the time in intercom systems, which is great. One use case scenario I could see is one transmitter, multiple receivers. One channel is for public use, one channel is for private use. Meaning I can program some of these to be left channel only or channel 1 only for public feed, and channel 2 is my private feed to my crew. Is that a use case?
It will absolutely do that.
Now we're going to go even one layer deeper. I think we're at layer number 2 now, right?
Or 3.
Which is I'm also able to transmit simultaneously with the two channels of audio timecode.
Well, that's right. There's a lot of metadata that is now included in Zaxcom wireless transmission. So you are transmitting timecode, and that you might say, how does that work out on set? I mean, if let's say the URX is owned by the production crew, the sound department, mm-hmm. you could simply walk up to a camera, take a cable plugged into the TA5 on the side, and jam the camera or jam a slate.
And you can also leave this on the camera, and one side will feed. You can make the output be one side timecode, one side audio.
That's right. On a camera, when it's outputting timecode, it's a mono receive. It can mix the stereo together, but it's right. A mono output and timecode. So you can absolutely use this as a receiver for a camera. And
does it have the sort of legacy benefits of freewheeling? If it loses a signal for a second, it'll freewheel past and timecode will still be accurate?
Absolutely. The beautiful part about this is, as opposed from, let's say like a timecode box solution where they have to be jammed, whatever is happening at the sound card that's being broadcast, if the timecode were to change because someone, for some reason, changed the master generator, all of these would instantly have the right time code, and the time code output of this is super, super stable. There's literally no jitter in it, and it's compatible with every camera out there. The other thing that's interesting about timecode is it automatically finds the correct rate based on what it's receiving. So it's not like you have to go on set every day and say, okay, well, I just started a new production. This one's 29.97, the last one was 30, so I have to go reset all my units. No.
So no fiddling with frame rates, it just automatically
No
recognizes.
fiddling with frame rates, no fiddling with manual jamming. You just turn it on and you're good to go.
Okay, next layer of the onion, I think we should talk about the reception qualities of this receiver. I see one antenna here. Is it a diversity reception system? And if so, how does that work in this?
It's actually a diversity system. It's an antenna diversity system. So as you see, there's one antenna on it, and the other antenna actually happens to be the headphone jack. So you've got two distinct antennas. It happens to work very, very well, giving you excellent range and dropout protection. What we wanted to do, or I wanted to do from I just touched my microphone. What we wanted to do from a design standpoint is we didn't want this to look awkward. We think that, when you look at things on set, whether it be wireless transmitters, walkie-talkies, any number of things, they typically have one antenna, and that's what we wanted to stick with, one visible antenna, because we think it's something that is not awkward on set.
Now, do I degrade the reception if I take a little short output cable and to a camera, let's say? So if I have like a stereo mini to dual XLR, does that sort of mess with the other antenna?
No, you actually enhance it.
All right.
Anything plugged into the headphone jack, which certainly you need to have something in there.
No matter the length.
No matter the length, yeah. There is circuitry in it that matches the headphone cable to be proper in terms of an antenna. It's also quite proper in terms of a headphone jack as well. It's just totally hidden from the user. They don't know there's two antennas, and that's great, and it works very, very well.
I do, I do have one feature request for future versions of this, which would be to have a locking connector for the headphone. I'm sure it's not the first time you've heard that.
No, and I will tell you, I wanted to do that, but I could not find a 3.5 millimeter that accepts the 4 connections that's locking.
Oh.
It's not made. And I couldn't make it.
Talk to me. So it's your tip ring sleeve on this?
Yeah.
Why? How come?
Well, very simply, we have a lanyard.
And here this dovetails into the next use case.
This
is layer of onion.
All your fault.
Yeah. No.
I didn't bring this up.
Oh no.
Okay, we're dovetailing.
It's no. I think this is the next layer.
Okay. Well, there is I'm gonna just pull this for now. Oh, all right, that's okay.
Good. Okay.
Yeah. So this is the control lanyard, and this actually does have a locking connector on it if you want to have it there. But you plug the control lanyard into the headphone jack, and it actually is a 4-pin jack. I think you can see it's 4 pins.
Yeah.
Right. So you can plug this into the headphone jack. So you can plug this guy in, and then you plug your headphone into the lanyard over here, which again is a locking jack. And what this gives you, contrast notwithstanding, is you have a up and down button for volume, as well as a push-to-talk button for walkie-talkies. I know, dovetail into the next thing.
Yeah, now we're into the next layer.
Well, we're getting there.
Yeah.
We're getting there. And then there's a microphone. Now you can kind of see it in the reflection there. So you have a microphone as well. So there's volume up, down, as well as push-to-talk.
Right.
And through software, we can also reassign these buttons to be channel control as well.
So let's talk about the channel control.
Okay.
Because one of the exciting use case scenarios that I see is obviously we've talked about it receiving a signal from a transmitter on the cart, but this can also receive signals from any other Zaxcom transmitter. Now, this is really exciting for the sound department, I think, because let's say I'm a third or a boom operator and I go to wire up talent, or the mixer and I go to wire up talent in their trailer, away from the sound card.
Yes.
Normally, you'd have no easy way of checking everything after I've wired up the talent. But now I can wire up the talent in the trailer and then use this same receiver to tune into that actor's transmitter.
Well, that's right.
And I think it's important that we also talk about the permissions involved.
Yes.
Because not every receiver will be allowed or should be allowed to do that.
Right. I mean, basically here we've done something that just no one has ever done before. In being able to tune into individual transmitters, we've basically taken the whole QC concept and kind of moved it off to, boom operators or thirds or what have you. They're able to monitor directly any Zaxcom transmitter. And in fact, if we go to the overhead view, you'll see that this happens to have my name on a transmitter that we're monitoring. And if I change channel, well, let's do this. We'll properly change channel. So I just changed channel to a transmitter that is sitting on the desk that has Peter's name in it. And you'll see it's on 538.8. You can see the time code. You can see the battery level of the transmitter, so you know the battery level. And we're also adding the status of the internal Zaxcom recorder to this, so you'll have that also on this display.
I think it's a great tool for the sound department. It's really great. And so the lanyard can change channels, but now we're going to dive one layer deeper, and let's talk about the two-way communication possibilities that the lanyard opens up.
Sure. When we were designing this, what I try to do when I design any product is I try to look at something and say, okay, what else can it do? Is there another thing going on here that is important? And, when I've been on set, I've seen multiple people utilizing walkie-talkies and utilizing IFBs, and often they almost, have two headphones on their necks, or one headphone, and to use the walkie-talkie, they have to take it off their belt, and they have to, basically say, okay. So it's not an integrated thing.
Correct, yeah.
And I just felt that, if we could properly integrate a walkie-talkie into an IFB system, it'd be a really nice feature. So what we did is we basically, I'll go to the overhead camera view here. We put a TA5 on the side. And that TA5 does a few things for us. It gives us a locking connector when we use this as a camera link, but it also plugs directly into a walkie, typically a Motorola walkie. It doesn't have to be, but here's one, this is called a SL300. So now we're plugged into the SL300. So you would basically, wear the walkie, you would wear the URX100, and you'd be able to, with the push-to-talk on the lanyard, talk to anyone who's on their walkies. And when you receive audio, which you do through the SL300 or through any Motorola walkie, that gets sent to the URX100, and it gets mixed in to the IFB monitoring. And as such, you can take the walkie or the IFB and you can route them left, right, or center any way you'd like to do it. So you're not dealing with a situation where you're constantly throwing your headphones off to talk on a walkie. You're basically just able to take the lanyard and just plug the lanyard in and go.
And then you reply on the lanyard.
You reply on the lanyard, that's right. So
right now, you're plugging the lanyard where the headphones would normally go into an adapter that lets the audience hear the walkie. Is that right?
That is correct.
Okay, so what we have here is we're going to simulate the transmitter in your hand being a signal, let's say, from the sound cart. And then I'm going to pick up the walkie-talkie, and I'm going to transmit to what is on this table we'll simulate as somebody in the sound department, like a boom operator or a utility.
Sure.
And we've connected this, and if we go to the overhead so that people can see, we've connected the lanyard to a dual XLR male so that ideally in the broadcast they'll be able to hear what this hears.
Sure.
All right, so Jason, let's fade down our lavs, please. And go ahead.
Okay, so I am pretending to be the sound cart using the ZMT3 to talk to you.
And I am communicating to the sound utility or the boom operator at the same time. And now fade our lavs back up.
And then I can talk back to you through the walkie using the URX to transmit through the walkie that's plugged into it.
Right. And I think that, what's exciting to me is these things existed as individual pieces that somebody could cobble together, but it never existed in a way that's so integrated so that I can be listening in on IFB, deciding where exactly I want the audio to be sent to, left, right, or both ears, from any source, be able to respond to communications. So many, I day play, a few days a year these days, and the mixer might be trying to communicate with me, or I might need to communicate to somebody in the sound department, and they might hear my request, but have no way to acknowledge it easily. And this lets it be a very elegant, quick, I got you.
Oh, absolutely. And I think there's one other factor that we really have to talk about here, which is when we designed the URX100, we designed it with our 35 megahertz track tune front end. Mm-hmm. And the test we just did was pretty amazing in that the walkie-talkie is only about 6 or 7 inches away from the URX here. And the walkie was able to transmit to the other walkie, and it didn't have any effect over the IFB reception.
Yeah.
So, the RF has been set up so that you don't have walkie-talkies affecting IFB receivers, which is a pretty common thing on set these days, to have the transmission interrupted because of that kind of high-power communication that's relatively close to the frequencies that we do use for IFB.
I think you did a great job. I see, we're using Glenn's walkies, but these would work with the typical CP200s from Motorola that you would see on a film set. And I think it is really worthwhile for the sound department on a lot of jobs to just request from production walkies for themselves, reserve a channel for their own department's communication. That way, the sound utility or the boom operator, probably the sound utility, can tune into production or tune into the sound department's channel and be completely appraised of what's going on set. So so let's get into the sort of like nitty-gritty layer of the onion, which is things like battery life.
Sure. Battery life on the URX is about 8 hours on 3 alkaline batteries, about 10 hours on rechargeables, and about 12 to 13 on lithium.
And that's AA?
It's AA, okay. Absolutely, yeah.
Great.
So.
And the map pricing on this?
This guy is $895, mm-hmm. and the lanyard is, I believe, $50.
All right.
Yeah, so it's I think very, very cost effective.
And that includes a cable for a Motorola walkie, or do we have to specify that or make that?
Yeah, we don't include cables. All walkies are gonna, different walkies will have different cables. That's really something that the dealers would do for themselves and sell to the customers. Yeah.
All right, we've sliced the onion. We're not crying. Anything? Did we miss anything?
Well, yeah.
Okay.
I think something we wanted to do with this system, we wanted to be very smart about it. In fact, I kind of call it smart IFB. Mm-hmm. If you're using the IFB, the URX100 on a show, you might be in a position where you have to program up many channels, mm-hmm. meaning that you would have, let's say that you had 10 wireless on actors, you had the sound card transmitting, maybe you had sound bags transmitting, and that's a lot of URXs to set up. You would have to put in, each channel into all the URXs. So what we did is we came up with an app mm-hmm. that actually runs on a web browser, mm-hmm. and I can get this, I think, under the camera here. So let me open this up, and here we go. Okay. So I have to sort of tilt this up.
There we go.
So basically, we have this app, and the app allows us to work through a Raspberry Pi that would be connected to one of our stereo link transmitters. And if I go into frequencies/privileges, it allows me to choose all the channels that are in the URXs and basically allow me to enter in channels. Like if I wanted to say I wanted to receive 550.8, okay, I could say update. And now this channel is 550.8. I could also decide if this channel is available to be listened to by all URXs. If it's a limited channel, maybe it's on an actor that I want to make sure is not being monitored. I mean, this is a pretty big thing in order to set it up so that URXs can only monitor what they need to monitor or what they should monitor. We call this privilege. For instance, if a URX is owned by the sound department, then it would be able to listen to any transmitter it could find. If it's not owned by the sound department, then these privileges on a channel-by-channel basis would become very important.
Yes.
Because you certainly want to make sure that, whoever it happens to be, that doesn't have the privilege of listening to actors when they're not on set, absolutely cannot listen to them.
And that privilege is programmed into the transmitters.
That privilege is programmed into the transmitters, that's right.
Meaning if I took a URX to a Zaxcom show, I wouldn't be able to listen to stuff.
Generally speaking, no, you can't. You would need to have it set up for that production, and the privilege level would have to allow it to happen.
Good.
So, yeah, I think that when you look at it, this is the first IFB system that has ever been set up to monitor, literally any transmitter on location. So we had to be very careful in order to make sure that, the protection afforded by the sound department is going to be, something that is transferable to this system, so that, in the past, someone at a sound car would bring down a fader of someone who's not on set so it couldn't be rebroadcast. But now with the ability to directly monitor from any portable receiver, we had to take that and really make sure that functionality was in there. And this is how we did it. So I think it worked out very, very well.
So Glenn, walk me through how the app integrates with the camera link transmitter.
Sure. I mean, basically with the app will work with a Raspberry Pi, which is a web server. The Raspberry Pi plugs into our camera link. This is a standard Zaxcom camera link. And it would then receive the list of frequencies from the app and broadcast it to all of the URXs. So by doing that, we can avoid having to individually program all the URXs before a show. Literally, you could just power up, any number of URXs, 20, 30, 50, whatever it happens to be, and use this to broadcast the frequency list to the URX. The nice part is that once this receives the frequency list from the app, it actually resides inside this. So that if you want to just basically go into a menu and rebroadcast the list without the app, you can do that. And you're also going to be able to go to any of the frequencies listed and change them here manually.
So if I understand it correctly, I'm assigning a privilege to the transmitters on set.
The transmitters themselves will have privilege, yes.
And then I'm also saying which URX100s are able to receive at which privilege level.
Well, that's right. If the set absolutely wants to guarantee that no one is listening to them, they could enable the encryption, which is a separate feature so that only receivers and transmitters that have the same encryption code will be able to be monitored.
Got it.
Yeah. So there's a lot of protection in the system to make sure that the audio for any production stays with that production.
Right, because privacy really is so important in a system like this.
Oh, absolutely. And when you're basically breaking new ground with a system that, is able to do things that just were not, possible before this product was available, I mean, we have to be very careful. Being able to encrypt and limit the audio, I mean, we've been doing that since day one, and it is super important, especially in the IFB world.
Excellent. Thank you very much, Glenn, for stopping by.
Peter, thank you so much. Appreciate it.
You bet. Thank you for watching. Thanks to the crew. As always, visit the video archives at gothamsound.tv. Follow us on Facebook, Twitter, and Instagram. And please send ideas or questions to info@gothamsound.com. Leave your comments below. Thanks.